Hello everyone, good morning. You're welcome to SWAT Day 2 training, and yesterday we touched bases on how to prepare data for your SWAT model, and today we will start with a brief recap where we saw yesterday how to work with SWAT dataset, but before that we learned on programs at GeoTE, and so we welcome you to our capacity building program, which this 2-day training is part of. And in our capacity building we have GIS mentorship, where we help you with mentors that shape your career in GIS. So whichever sector you are, please reach out to us via our website. Also, this training has been part of the GIS short course. So to know more about GeoTE, visit our website, and we'll be happy to help and support you. All right, we touched bases yesterday on SWAT model, and we saw some different processes from the landscape to the channel processes, and then we also saw a difference between the previous SWAT and the current SWAT Plus, which is the landscape unit, which is an added feature in SWAT Plus tool. And we also learned about the hydrological processes in the soil profile, and we'll see them in the output today. We just did a theory check on weather as well, so we'll be interacting with weather data today. Yesterday we weren't able to create this, and also learn on channel and floodplain processes. This include flow or transport of nutrients and sediment in the channels. And we also learned on weaknesses of SWAT, which requires many data input, and this is a challenge to most of African countries where data is scarce. And also we saw calibration can be very complex in SWAT, especially the two types of calibration that we have in SWAT. And we also learned about the usefulness, which one of it is that it's free and open source, so anyone can use. Here are some of use cases of SWAT. It can be used in water quality and nutrients management, climate change impact studies as well. So we also learned how many water basins we had, and we have one map from GeoTE staff who created represented 9 water basins in Tanzania. Here are some of tools which we saw yesterday that are important for SWAT. SWAT Plus comes in a combination with SWAT editor and the SWAT toolbox. So installation of SWAT Plus alone will give you all these capabilities. So we learned yesterday how to create these 3 data sets. Today we will see how to run SWAT in QSWAT using or incorporating weather data. So we also did some fun breaks and learned a lot yesterday. So in the day 2 we will be touching bases on performing watershed delineation, and we'll create HRUs, which are hydrological response units, and apply some thresholds. We'll edit the model inputs and run SWAT, and also we will analyze and compare scenarios output. So this might depend on the time, but I hope we'll also visualize the results. Now it's better to understand our catchment size, which we will see, and before that we also need to understand how water flows in the catchment. So we have the sub-basins from the watershed or the basin, we have the sub-basins, and then the landscape units, and then the hydrological response unit. Consider HRUs are independent, let's say, land use or activities on the land that helps identify the hydrology and nutrients flow. So the basic unit of SWAT, I would say, is the hydrological response unit. And now in SWAT Plus, we can be able to simulate landscape processes such as those in the floodplain or in the upper areas. And all this makes what we call the sub-basin. And yeah, so that's how water flow. Now, before we dig in, let's just open QGIS and learn how to understand the area of our water basin that we'll be working on. It's the same study area we did yesterday. So I have my data set here on the desktop. So I'll be using that. In QGIS, what you need to do first is add data using the browser panel. That's what I use. And then in adding this data, you go to the directory. So here is home, and then I'll find the desktop, and then after desktop, this is the training folder, and then here I'll find the training data that I supported you guys to use, and then I'll find the study area here. The study area, I'll select the TZA part, drag and drop in QGIS. And in QGIS, there is what we call the layer panel. From the layer panel, please right click this and then open the attribute table. Now we already have the area calculated here, so simply the way you do this is maybe create a new field, and then we name the field name as area. This is simply the column, and then we'll assign it as a data type in decimals. I'll put it to 0 decimal point just to get the exact area. I don't want decimals, then I'll do OK. All right, yeah, sure. Let me add it again here. I'll add area. That's an error that happened, so I selected the decimal number, and then when I put a 0, I would rather use an integer rather than a decimal number, so I'll leave it as that. Failed to add field area. Oh yeah, I've repeated this sorry, the name here, so it's either maybe I would delete this and then maybe add it again. Apologies for that. So what you need to do is use this tool here to delete the existing column. So I'll add it again just to show you how area is calculated, and then I'll select decimals rather, sorry. So I'll put a 0 or 1 decimal point, that will be fine. Then I'll have this one as the attribute. Then I'll use the field calculator to calculate what we call the area. So use geometry and then area. So I'll use this sign dollar area, and then it will have a preview of the area here, and in the expression we would have the expression, but for us we will be updating an existing field, so the existing field will be updating its area. So we select area and apply OK, so we'll have our area. So this is approximately like 5,400 kilometers square of our watershed. So this is basically optional. I just wanted to kickstart with this. You can simply just discard this. So let's begin running SWAT. To start running SWAT, just click this QSWAT here, and now we'll just be filling in the parameters that are needed. First, we need to create a project, so a new project. This is the training data set. For me, I'll just put it here in the desktop. I'll create a new folder here in the desktop. So the folder is SWAT. I'll take the SWAT. I'll put it in the desktop just to minimize the search directory for the model to run effectively. So that's like advisable. You'll also put it in maybe a local disk D or C. Yeah. So you don't want to put it inside a lot of folders in here. So I'll select SWAT and then select folder, and then I'll enter the project name, the QGIS project name, which is as well SWAT. Then say OK. Now this will open what we call a dialog box. From the steps, we get step 1 to step 3, and this will help us add data that we created yesterday. So step 1, we will delineate a watershed here. So click that one. In here, we select the DEM. So the DEM is in the folder that I shared with you, or we created yesterday. So you use any of these two folders. So I'll go and use DEM here and select this one and then open. All right, so it will take some time because this is a bit huge DEM, and it says it should take some time processing. It's because it's so huge and we need to just to be patient, so it's just a normal error. Yeah, okay, so here we need to like put in what we call existing stream network, if we have that one. So I do have that one from my end from the training data I shared, but we didn't create that yesterday, so you can either opt to put it or not. So for this demonstration, I will put it. So it's in the streams, and then the stream projected as shapefile, then open that one. So basically it will have a threshold. So a threshold is simply a minimum area required to create a channel on our stream network. So the higher the area, the lesser number of streams. So this is advisable to like have less number of streams for model efficiency and simplification of our model. So this is represented in square kilometers. So I'll just use create to create my streams in my study area. So it will take some time to finish up this process. So we just need to be patient. Yeah. All right, so after that we will have our stream networks here. Sorry, apologies. Let me wait for it to work out. Yeah, it's finalizing, so let's hold on a bit. This entirely depends on the computing power of your computer, so you need to be patient. Yeah, there it is, almost done. Yeah, that should be done in several minutes, so I'll pause this here. But again, you'd see some channels and created in our existing stream there. There's no need to pause right now, so I will just minimize this one and then go back to the streams here. So in this dialog box here, I will have the stream burning, which is the ones I provided area, and this here are the stream network that SWAT created from our DEM. And what we'll need to do next is define the inlet and outlet. This simply specifies where our outlet is in our watershed. So you can use a shapefile if you have it, but for us we just go and draw that one. And for us we'll do the outlet from here. So we will select this closer to this area here, so we'll have that as our outlet and say OK, and so it automatically fills in that shapefile, creates that shapefile there and fills it in. So to see if we are we have our outlet, we can review and we find one snapped, which is fine, and this is just a threshold distance. If it's a bit far away, you can change this number to make sure it gets the what we call the outlet. So after that, I think you can now create your watershed here by clicking create watershed. So this will also take a bit of time depending on the speed of your computer, but this one so I'll just pause it and then continue to do the recording. All right, now we are good to go. As you can see on the layer panel, we have our sub-basins here. I'll just zoom out in our catchment and see we have created some sub-basins in our watershed. So the next step is creating what we call landscape. Now this is more, this all options here below are optional. You would add lakes if you have lakes in here, and these areas, all reservoirs and everything, to help your model understand what scenarios you're dealing with. And maybe you're interested with looking at sedimentation in the certain dam here. That's another thing you would consider in your study area. You would also do a merge of sub-basins if you want to do a merge of smaller sub-basins. So I'll do that, maybe merge 1 or 2 to demonstrate. So to do that, I'll select a sub-basin through using a selection tool, the first sub-basin, and hold control and merge it with probably this one, and then after that I'll minimize this window here and say save. And so here I will be given an option to merge those sub-basins by clicking merge. So it will merge the two sub-basins here. You can continue doing this just to make sure that you have simple and I would say favorable sub-basins for your model to learn effectively without errors. You would continue that by selecting and merging. I've already said how to add legs. You just add the shapefile of that leg there, but you'd also be able to create landscape in SWAT plus. In SWAT, you were not able to do that, or like have this feature here. So you can create this using several options. There's inversion here, and then we have another algorithm that is branch, but you will also use a buffer channel Buffer channel estimates the width of the stream or channel, and then it applies this multiplier here to calculate the floodplain and upland areas. So you can choose any of these options to do that. I would want also to reduce just a number of buffer multipliers and create, and so I'll leave it to run so that we could have the um, landscape units. So it will take some time depending on your processing, but I have an error in this tool. So what I will do is maybe use another option here. I'll increase this to this number and maybe create using the DEM version. So that will take some time. So I'll pause it for it to run and create for me the floodplain in the upland areas. Alright, now that is done. So if it completes learning, you just click done here, and then we will see something like this in your project. So these are areas of the floodplain, and the ones that are not demarcated are upslope areas. So this is based on the so we will find the floodplain here, and this is entirely based on the inversion method. Yeah, so after you have done that, which is actually very optional for you to do, you can go ahead and click OK. So by clicking OK, you let your watershed delineate gives you several outputs such as the number of subbasins that you have, and it will also do a fill of sinks and every kind of they call it TOWDEM. So TOWDEM is all those processes around filling in things in your data. Yeah, so after that, in a while, you'll see create HRU activated after the first step. So you go ahead, click that. So this process is actually straightforward. So you select the land use map, which is your data set for the land use. So in the training data, you'd have the land use, and then for us, we select this projected, open it, and then in the soil, we'll also select the soil we created, which is similar to this data here, the TIFF file of soil. Another thing is you want to add the lookup tables. So this one is the CSV file that we also created. Now this is a soil lookup table. We want a land use lookup table. We go to the folder of land use and then select this lookup table. Now if you want to open it or view it, you can simply just right click and see what it is. So you'd also want to select, so yeah, here land use and then the CSV, this one, open, and then we'll also select a soil lookup table, which is a CSV. Now we go to the training soil and then this lookup table here, and then you'll define the user soil as file because we don't have a CSV for our user soil data, but this one is the soil we downloaded from file, and yeah, it's okay putting this option here. In installing SWAT Plus, there are other soil data set that they come up with the installation. So if you downloaded that, you might select any of this. Now in the slope analysis, we found out our slope was The majority of the area was 25% slope, and it didn't exceed 52. So here you put ranges. So let's say the first one is 12, and then press enter. The next one is 25, and then this gives us a range from 0 to 12 slope, 12 to 25, and the one that is higher. So this is maximum, this is minimum. This number doesn't mean that one is a 99% slope, rather the maximum value. You'd also want to merge the channels. So the channels, the landscape units feed or drains water into the channels, and then later on that is fed into the streams. Yeah. So in the reservoir threshold, we don't have any lakes added. So this tells us that we will only use this value. Tells us that we will not use any. We don't have any floodplain, so there is no floodplain in our landscape. But if you did add, you'd be able to change these values in terms of reservoir threshold. Now you click generate full HRUs. From there, just read from map and read it. So it tells me I have at least one floodplain because I did the landscape the landscape analysis. So there's an option here. Let's say select here in the select floodplain. So this is the floodplain which I showed you in the layer panel. So you can select that one. It's basically optional, and so you would read it here. So by clicking read, it will take some time as well to read out the land use and soil data and to create the hydrological response unit. So this takes a bit of time. I'll just pause this, and I'll be back when this is done. Alright, it's almost done. Yeah, so let's just wait for it to complete, and yeah, we're done. So after this has done running, we would have the number of sub-basin count 25. We have 276 channels, and we have 5,122 HRUs. So we would want to filter these HRUs from this tab here, and for us we can select. We have these filtering methods here. The dominant filtering method selects select one HRU in each landscape unit formed from the land use, soil, and slope, and this one it will only select one HRU in each landscape unit. So we'll also use a filter by percent, so we can use maybe a 20% filter or a 10% filter, and then click go. Then we do also a 10% filter to the soil, and then here as well 10% filter. You would use area as well if you don't want to filter the percentage of landscape unit. You can use the area, and in this target number HRUs, you can just pick a number out of those 5,000 HRUs. So that should be all good. So I'll just select 10% HRU, and what this means is all this in here are HRUs, these boxes. So this is just simple one HRU, but then there are many that are have a minimal or insignificant effect in our model, and we don't want to to make our model use much computing space and take a long time to learn, so we filter them out. After filtering, you will find some gaps in these HRUs that were created, and those gaps are the ones that they were filtered out. So I'll minimize this one and now create the HRUs that will be created after the filter. So I'll just use the create HRU, and this will also take a bit of some time, so I will pause and continue from there. All right, now that process was complete successfully, and we have the edit inputs and run SWAT. So if you go back to the project, you find some gaps that were omitted. These were the HRUs with less than 10% of the filters I specified. So that is well and good. Okay. Next, we would want to continue running the model. Now, what this does is you will edit these inputs in the SWAT plus editor. So we'll move away from QSWAT. It will take this data into the SWAT plus editor, and there you'll be able to edit some inputs and run the model. So click edit and edit inputs and run SWAT. But before, there are several tables you would preview, like several reports. Let's say land use report. You would see some reports here on the watershed, the landscape units, the land use soil, and each sub-basin as well. They are located here, and also some channels in each sub-basins. All right, so that is optional, but you'd always want to go check in. You'd go check in the tables. Now, for the last step, please click edited input run and run SWAT here. All right. So I'll minimize this one. Yeah, so click edit inputs and run SWAT, and then this it asks me, do you want to allow public private network? I'll say allow. No worries. Yeah, so it will open the SWAT plus editor, and then here we just specify the project name or the location of your project. So this is already our QGIS project that we saved as SWAT, and in here you would write maybe Tanzania. It's where we have this project in, which is also fine, but it's optional. Then you click start. So after clicking start, you'll be able to input your data from the QSWAT to the SWAT plus editor, and here you have a summary of your HRUs. So from the 5,000 HRUs, I have now 1,841 HRUs. I have this number of channels and 25 subbasins, and our area is covered mostly by pastoral land, something like that. So this is just an overview of the SWAT. So this is the baseline model. It has this total area and estimate because we left out some of the areas. As you can see in the SWAT, we have some area that was left out. Yeah, so we had some area that is all right. here, just on the right part there, we left some areas. Looks like the area has decreased from that we calculated area. So with that said, there's also a temporal simulation period. We'll always be able to change or edit this. And yes, this is the date that this project was created. To get started, I think you need to just click edit inputs here. And so what was missing in our model was weather generated data, and you can add weather generated data from here. While installing SWAT Plus, we checked import data, the weather generated data, so you can simply import through this option. And we use this spatial query language light file for the weather generated data. So this is available in your folder or in the database. So if you're using your observed weather data, you want to check here, but for us, we just click import and it will just import the weather generated data here. It will have almost 30, we have almost 32 rain years, and this is the location of the weather stations, and we have the elevation here. Another option is putting in the weather station data, but for us we just simulate them because we don't have weather station data. If you have one, you would always use this import option here to add your own measured weather data. With that said, I think now you're able to click run the model and through this option, but you'd also want to visualize other kind of options that you have here. Yeah, so let's just go ahead and run SWAT. Now, before you run SWAT, there are some of the customization you would need to do. This includes the running period. So here you'll be able to change. So maybe you'd want to simulate from 1990. So I'll select, I'll just scroll down to 1990, and then that's January 1990, January 1st, and then to probably maybe I'll go simulate it to maybe 1996. Then select that year and specify the month and the date, so 1st 1996. After that, you would also want to choose what you want to output as your data or your table. So this is a channel. You can select everything that you need from here, but for us, we'll just select the channel here. So we'll put daily and monthly, that should do. And if you select a lot of outputs here, it means it will take more time for the model to learn. So and then we'll also have a warm-up period, which is 1 as a default one. This is just a number here for the model to iterate first before running the other output here. So this is like a warm-up time frame for the model to do the warm-up before executing. And then after that, I think those are the only settings you might be interested with. And so you would go ahead, save the settings, and then run your model. So just click that, and so the model will start running. So this might take some time, so I will resume just after the model is about to complete. So yeah, it's about to, but I just wanted to show you it's running still, and now it's running the simulation years from 1991 to 1996. So it's 2 out of 7. I'll also pause it again, Make sure to save time, waiting time for the model to run. I'll be back once it's ready. Alright, now it has completed learning the SWAT model under our default scenario. So in here you'd find in the SWAT folder, you'd find the scenario folder, which every scenario will be saved in there. So now we have only a default scenario in that folder. Now, one important thing you want to check is you run SWAT plus check just to get an overview of your or summary of your watershed. So go ahead, click that one. Then this one will give you a summary of what's happening in your watershed. Now I would say mine took a long time because of the number of HRUs. We have 7 years, one warmer period, and the weather data is simulated. It's not measured. We have the HRUs, the landscape units, and the subbasins here. Okay, so you'd also look at the hydrology, and so in your watershed, this is how this is the surface flow, surface runoff rather, and all units are in millimeters, and you would have the evapotranspiration and some messages and warnings. You can definitely check this nitrogen cycle in your watershed, phosphorus cycle, and all units are stated here. In the plant growth, say unusual low for phosphorus stress, and these are some of the parameters in the plant growth. So these are checks that you do to see how your default model worked. We didn't have any reservoirs, so it will be 0 here. Now, after doing that, we'll click here, exit SWAT plus editor to go back in QSWAT. Yeah. And then if you go back in QSWAT, it opens the step number 4, which is visualize. Here you'll be able to visualize several tables and their variables. So click visualize to open this dialog box here, and I'll just minimize this and then have our table. Sorry, so I want our table, visualization table here, and so we have only one scenario. As I said, it's a default scenario, and then this is the tables that are available. Sorry, apologies. So I'll go back here and drop down and select one table here. So this is the channel sediment, sediment and nutrients and storage. So you just place a cursor and see what that shortcut means, or that abbreviation. So this gives the channels outgoing sediment and nutrients. Now here is this time scale. We simulated our model from 1991 to 1996. So you can use animated maps here. So the animated maps basically simulates the flow of your nutrients in the channels. So here you select a variable. So we are interested, there are a lot of variables here, but I would want to choose the flow out variable, and I'll use the current. Sorry, it's loading. Yeah, this one is just because of your computer, so you need to be patient with it. And the catchment is a bit huge, so you might just want to be patient as it loads. Yeah, so after selecting the variable as flow out, you can use a map canvas to play the date. I didn't specify the year. That's why it is loading. Let me pause a bit. So I had to reset again, but here you select the default scenario. Here you select the channel by monthly. Daily it will take a lot of time to run because you have 7 years, but you do that for maybe 1 or 2. But so I'll do a monthly check, and then I'll do it from January. You'd select any month you'd want, so maybe February or January to this end date, and then you'd want to do an animation. Here in the variable, you want to select maybe the output, and yeah, so it will simulate from the month you tell it. Another thing you'd want to do, you'd also record this output here by clicking record, but you'd play here to just know how the water is flowing in each month of your sub-basin. You'd find a project name and the years and the flow of water in every channel. So what I'll do, I'll just minimize this one a bit to somewhere here so that we could see the flow. You'd also want to pause and maybe add speed. Other things, maybe we want to hide the HRUs so that we could see HRUs together with I think it's the I'm finding some data to hide. So we have the aquifers. Yeah, so we remain with the sub-basins and the channels together with the stream. So I'll just minimize this one a bit to minimize this one, and then again get it here. So I'll have my SWAT. I just want to position it so that we could see what's happening in the model here. So this is the visualization, and so you can just record, or you would always want to start. I've just added more speed to this visualization, so I can start recording here and then click play, and then it will record the time series of the water out in terms of meter cubic per second, and that's how water flows out from the HRUs landscape units to our outlet. So that's one of the visualization you could do in SWAT. Another thing that you do is plots, and in plots you can, this is a scenario, and you could add several plots here. So the first thing, you select the variable, and then number 2, you can also opt to put observed data here to just compare what the model has simulated. So you select a plot type, so maybe you need a bar graph or a chart, and that is typically your choice. Then here are the list of the channels. So maybe you want to know the flow or the table of channel 1. Here it's where you select the channel, and to know the channel you would just come here and see and use the identify tool and maybe select that, and you'll see this one is channel number 10 and this one is channel number 9. So our outlet is channel number 9. So you come back to our model, our visualization dialog. Let me just open it a little quick here. Let me find our QGIS. So this one, and then our dialog is here. So what we need to do is select the variable that we would want, similar to what we did in the visualization of the output. So we'll take, for instance, flow out or water out, and then we need to add that scenario here. Now you'd compare this with any other data set. Maybe you want to compare flow out and flow in, so I'll come change and select flow in. Finding flow in, yeah, flow in, this one, and then add that there, and then you click plot. Yeah, there is insufficient data for here 1996. I'll say okay. So I'll go back to maybe 1994. I'll just change the years and then plot that one, and then it will save this data in the scenario tab. So this is plot of flow in. Plot, I'll just save it as plot maybe, then click save, and it will visualize the flow. So this is flow in blue, so we don't have flow in, but in 1991 we have flow out values here. Sorry, yeah, so we do have values in flow in and flow out, but we can customize how that is visualized. You could use scatter plot, you could use flow load or linear graph, and then you could also use a bar. So maybe use flow duration curve and then update. Yeah, so this is how you visualize your variables in this visualize option. You do a lot of things. You would also want to export static maps here of different variables. Again, maybe the nitrate stored in the end of time period. There's a lot to explore. With that said, we have reached the end of our training for day 2, and just to do a little bit of recap, what we have done is we have learned how water flows in the sub-basins. We have delineated our watershed. We have created a hydrological response unit. We have edited inputs and run SWAT. The inputs we have added are weather data and run SWAT. And then we saw SWAT plus output and scenario. And then next time we will see scenario comparison, how to change different scenarios for our um, watershed. Now, just a highlight, SWAT scenarios are in major two families. You'll change climate you'll have climate scenarios such as change of rainfall and temperature, and once you alter that, you would see or evaluate what are the outputs when you change those scenarios in our watershed. Other kind of scenarios are land management scenarios, where you change a certain land use to a different one and see the impact on the hydrology and other kind of variables in the watershed. So this include farming practices, irrigation, and maybe sediment in the reservoir. Yeah, so these are some other things. So we also shared good modeling practices, which I think we began using this for since day one, such as maintaining projections in your SWAT, because SWAT uses measurements such as meters, so you'd want your data to be in projected coordinate system. And yeah, I think others are don't oversimplify the model, for instance, in the HRU selection and merging subbasin and many other that you have. So this is the end of day 2, and see you next time. If we have any program, please reach out to us via www.geote.org, or simply you can email us at info@geote.org. Thank you so much. Yes.